Hello, Mr. Richards here, and today's lesson is on representing linear functions. You'll learn how to solve linear functions with two variables and how to graph linear functions using ordered pairs. And before we get into our examples, let's first define a few things. What is a linear equation? Well, an equation such as y equals 50x is an example of a linear equation. It is an equation whose graph is a line and the solution contains or consists of two numbers one for each variable that make the equation true. Now compare that to a linear function. A linear function is a function in which the graph of the solutions forms a straight line. And one of the ways to find solutions is to make a function table. And a function table shows the values for x and y and the function rule. Now let's see how this works when we try to find solutions of functions. Find four solutions of y equals 4x plus 3. Write the solutions as ordered pairs. Well, we're going to make a function table here, and our first column is going to be x. Our second column is going to be our rule, y equals 4x plus 3. Our third column is going to be our resulting y. And our last column is going to be our ordered pairs, x, comma, y. Now if we remember back with domain and ranges of functions, the domains are our independent variable and they are also our x values. And we get to come up with those x values. We get to make them up. And so typically what you can do with most of these is you should have some negatives, 0, and some positives. And I like to use -2, -1, 0, 1, and 2 for x. So we're going to put those x values into the function. So y equals 4 times -2 plus 3. And we can fill these out for the rest of the column. Y equals 4 times -1 plus 3. Then y equals 4 times 0 plus 3. Y equals 4 times 1 plus 3, and you can see where we're substituting in the x values into the function. And lastly, y equals 4 times 2 plus 3. Now for our next column, we get to evaluate the function. 4 times -2 is -8, plus 3 is -5. 4 times -1 is -4, plus 3 is -1. 4 times 0 is 0, plus 3 is 3. 4 times 1 is 4, plus 3 is 7. 4 times 2 is 8, plus 3 is 11. And now we write these as ordered pairs. Our x values always are first in our ordered pairs, so we can write -2, -5, then -1, -1, 0, 3, 1, 7, and 2, 11, and that is our solution. We can also use function equations in real-world problems. So at a local software company, X level 1 employees earn $48,000, and Y level 2 employees each earn $24,000. Find two solutions of 48,000X plus 24,000Y equals 216,000 to determine how many employees at each level the company can hire for $216,000. Explain each solution. Well, right now our function is in this form where we have 48,000 x plus 24,000 y equals 216,000. What we really want to do is try to get the y alone. We want to try to solve for this y. We want this y to be alone. So if I start by subtracting 48,000x from both sides of this equation, or this function, I would have this cancel out and be left with 24,000y equals 216,000 minus 48,000x. And if I divide both sides by this 24,000, I'll need to divide everything on this right side by 24,000. This ends up canceling, and I'm left with y equals 9 minus 2x. Or the same thing as y equals -2x plus 9. Both work in this situation. And what we're going to do now is use this simplified function to find two solutions. So we can start off with our x, with our y equals -2x plus 9, and then our y. Well, for the x, let's pick positive numbers. We cannot have negative employees, so we'll just pick 1 and say 2. Well, if I plug that into the function, y equals -2 times 1 plus 9, and then y equals -2 times 2 plus 9. -2 times 1 is -2. Plus 9 is 7. 2 times -2 is -4. Plus 9 is 5. Now, what do these solutions actually mean? Well, a solution of 1, 7 means I can have one level x, or one level 1 employee, since our x was our level 1 employees, and 7 level 2 employees. What does the ordered pair 2, 5 mean? Well, that means I could have 2 level 1 employees and 5 level 2. So we took our function and we solved for y by moving our x to the other side and then dividing the 24,000. The key here was dividing it by everything. And then, using that function, we came up with values for x like 1 and 2. You could certainly use 0 or 3 or 4 and see how that works as well. And then we interpreted our solution saying, okay, 1.7 means they can hire 1 level 1 employee and 7 level 2 employees. 2.5 means they can hire 2 level 1 employees and 5 level 2 employees. So now that we've solved linear functions with two variables by making a table of ordered pairs and using function equations, we can now look to graph linear functions using ordered pairs. And we're going to do this by using the x and y intercepts. And to figure out what the x and y intercepts are, I think the best way is actually to draw a picture. If I draw my axes, I have my x-axis and my y-axis. And if I just draw in a function or a line that looks like this, the point here where our line intersects the y-axis, that is known as the y-intercept, as it crosses the y-axis. This point here on the x-axis is known as the x-intercept. Now there is something important here about the actual points of the x and y-intercept. The x-intercept here might be something like the point 2, 0, whereas the y-intercept up there might be at the point 0, 2. Something key about the y-intercept is that the x equals 0, and something key about the x-intercept is that the y is always going to equal 0. And so we're going to use that to help us graph. So it says graph y equals x plus 2. We're going to do this by using the intercepts. Well, to find the x-intercept is where y equals 0. So if I take y equals x plus 2, to find the x-intercept, let y equal 0. So say, okay, 0 equals x plus 2. And now I can solve for x. If I subtract 2 from both sides here, I get negative 2 equals x, which gives me the ordered pair negative 2, 0, which is right here. That is my x-intercept, and I found it by letting y equal 0. What about the y-intercept? Well, we're going to let the x equal 0. So if I start off with the same equation, y equals x plus 2, I can make my x equal to 0 here and say, all right, y equals 2. So this is the point 0, 2, which is right here on our graph. That's the y-intercept at 0, 2. And I can now draw in a line connecting these 2 points. I can label this line as the graph y equals x plus 2, and that's my graph. Now it is a good idea to check our solution. How can we do that? Well, if we're looking on this line, one way of doing this is saying, okay, where can I see a solid point? Well, right here, I have the point negative 1, 1. So if I take, in a check step here, y equals x plus 2, and if I substitute it in negative 1 for x and 1 for y, does it work? Well, 1 for y, negative 1 for x, negative 1 plus 2 is 1, and 1 equals 1, so yes, that appears to work. While 2 points make up a line, it's always good to check a third just to make sure you're right. And the way we did that was by picking a point on that line and putting it into our function. Now, to use function notation in a word problem, Nikos walked 3 miles today and plans to walk 1 5/10 miles, or 1.5 miles, every day from now on. The total number of miles walked y can be represented by y equals 1 5/10 x plus 3, where x is the number of days walked after today. Our first goal here in A is to state the x and y intercepts and then graph the equation. Well, to find the x-intercept, we need to let y equal 0. So we'll have y equals 1 5/10 x plus 3. Our y needs to equal 0. So 0 equals 1 5/10 x plus 3. And now I can solve for that x point. -3 equals 1 5/10 x. Then divide by 1 5/10 on both sides. And -2 equals x. So this is the point then of my x-intercept, -2, 0. So -2, 0 is right here, and that is my x-intercept, where I cross the x-axis. Now what about the y-intercept? Well, that is going to be where x equals 0. And so if I have the same function, y equals 1 5/10 x plus 3, and we put in 0 for x, y is going to equal 1 5/10 times 0 plus 3. Well, 1 5/10 times 0 is 0, so y is going to equal 3. So now I have the ordered pair 0, 3, which is right here. And so now I can draw the graph, or a line for this graph, like so. And there is my line. Now, what was my x? My x were my number of days. And my y's represented the number of miles. And that is helpful when it comes time to interpret our intercepts. Well, for our x-intercept of -2, 0, this is actually not possible. We can say this does not apply, since we cannot have a negative number of days. I mean, the x-intercept, -2, 0, infers that we have negative days. That simply can't happen. But the y-intercept, which is at 0, 3, means that 3 miles is Nico's initial distance before his planned 1.5 miles per day. Because remember, he walked 3 miles today and then 1.5 miles every day. So the x-intercept of -2, 0 does not apply, since you can't have a negative number of days. But the y-intercept of 0, 3 says, okay, at day 0 I already went 3 miles. And so now I'm going to be walking 1.5 miles each day, and that's the rest of the line. That is it for this lesson on representing linear functions.